we receive forgings, and the forgings are taken from the truck by forklift over to a receiving inspection area. And at receiving inspection area, all the boxes are staged accordingly, and then they await receiving inspection. Staging of the forgings, an inspector comes within 1 or 2 days and performs a receiving inspection. The gauges are brought from the quality control room over to this area to perform the required inspections. After the inspections are completed, the boxes are moved to a storage area, and we'll show you that next.
One of the first things that I recognize is that we bring the parts in and we store them right in front of an open head door. And from times that we've done these before, there's weathered in there with rain, and some of them have been rusted, so we've had to rework them. And I see a lot of waste right off the get-go, and just where we actually put them, where we started.
Yeah, because we actually have to take the parts back and sandblast the rust off of the areas that are just forged that will not be machined, so that the customer doesn't receive a rusty part. The other thing that I see is I wonder why we are moving all these parts to this area. For one thing, it's roughly 50 to 75 feet from the dock. This is all done with the tow motor, and it takes the tow motor operator, approximately 15 minutes, 20 minutes to move several boxes out of a truck and to this area. And then after they've been inspected in this area, they're being hauled past the dock to a pallet rack, which is probably another 50 feet the other side of the dock. So they're traveling somewhere around 100 feet or maybe more to the pallet rack.
How much time do you think, like as far as tow motor time, you said roughly about 15 minutes
I'd
to
say
unload the
15
truck,
to 20 minutes to unload the truck.
and probably another 15 minutes to pick them up from the receiving area back to the pallet rack.
So you've already got anywhere from a half an hour to 45 minutes in these parts, and they're going to storage. And this is tying one person up for that amount of time. A possible suggestion to this could be maybe we should consider looking into checking with QA to see if QA agrees with a process where we pull parts from each box and have the labels pre-made for those boxes so that they go on the rack directly from the truck, and the person putting them on the pallet rack from the truck pulls 1 or 2 parts from that box to verify that they're the right parts and they're in the tolerances of the forgings, and mark the box and mark the part so that we know what part came out of what box. And then he's going to have, if he's got 10 or 12 boxes that come in, he's going to have anywhere from 10 to 24 parts to inspect.
Yeah, that would help eliminate those being subject to weather also right off the get-go.
Going directly to the center of the building to a pallet.
Scott, what about the idea you had about the samples and tagging them and
Well, the idea with the pulling the samples from the boxes would eliminate the parts needing to go, the boxes needing to go to inspection for inspection. It would be just a sampling from each box. So if we have receiving tags made up for that part number and have them numbered 1 through 12, if we've got 12 boxes coming in, if those are made up ahead of time, then the person unloading them can simply write a date on it and a number showing that they came off of that box. The tags, we normally staple the tags to the box anyways, but that's done after they're inspected. So if we identify the box coming off the truck and take a sample from it and identify the part with a marker so that we know that it came out of box 1, then the parts could be palletized directly off the truck instead of going 50 to 75 feet to that inspection area, setting in that inspection area, tying up floor space for 1 to 2 days before they're inspected, and then hauled another 75 to 100 feet and put on a 16-foot high pallet rack.
And let me add to that, again, if you're gonna move the entire box and not the sample, you're gonna look for the forklift truck. What if that forklift truck has been taken away to some other location to load a fixture or move some parts? So not only do you have this transportation waste and inspection delay, but then you have another delay where this forklift is being waited upon to be brought to take this whole box in. So, it's like a cascading effect in terms of all the waste that you add. So very good point there.
And when you say that also, I know how it works when you're on the shop floor. If you go to get the tow motor and somebody is using it and it's not available to you, you're going to have downtime. The person that's waiting on the tow motor isn't going to busy themselves with things that need to be done. They're going to wait on that tow motor. They're not going to be performing a task.
Let that be written on a slab of stone and brought down from the mountaintop.
Amen.
Our storage containers primarily consist of 2 different types. One is a larger wooden type container, which you see being stored on the left-hand side. And then on the right-hand side of the storage racks, you see a smaller cardboard type box, which is forgings as well.
Well, I don't know about any of you, but what I saw there was a mess.
Yeah, a lot of hoppers in front of the bigger wooden containers.
Yeah, we've got, in the beginning of that video, when it was on the left side of the rack, we could see that we had a hopper sitting there, we had empty containers sitting there.
Yeah.
All of that stuff has to be moved to
Yeah.
even load anything onto that rack.
You had 2 rows of objects you have to move before you can even get to the rack to get the parts off.
So let me ask you this, how would you cost the lost labor time? I mean, clearly somebody who's gonna try and access something that's kind of behind this box or behind these pallets is gonna have to move this stuff. So think about the process, that the guy will probably go look for a pallet jack or a forklift.
Yeah.
So there's gonna be time to go look for that device, come back with it. That gentleman will probably move this out of the way and put it someplace else which blocks somebody else's
Yeah.
access in the future. So you see labor time lost essentially.
Yes, labor time lost and going to find the tools to move boxes. Some of those boxes sitting in front of the rack are not empties, and you can't just slide them out of the way. So you have to find the tools to move it, and then it's an aggravation.
Yeah.
It is an aggravation to have to move things to get to the things you need when it should be more organized than that.
So other than just the 7 forms of waste, we got another one like a safety issue with all those things piled up in front of there.
Yeah, it can be a safety issue too. Because if somebody goes back there who's maybe not regularly a material handler, who's just filling in some time while their machine's being set up or a changeover or something, and they go back there to get an empty box, or they go back to get a pallet of parts off of the floor and they can use a pallet jack, then they may be trying to move that large stack of boxes with a pallet jack, which they shouldn't be doing.
See, and here's the other issue. Remember we talked about inventory waste and overproduction waste, and you're talking about safety. I may not know much about the purchasing strategy, but typically people talk about quantity discounts. If you buy in bulk from us, hey, it'll be very good, you'll get a discount, but then you end up storing a whole amount of space of the same product, which might last for several months. So the question to ask is that, given how much you see of pretty much what I might think are the same forgings, could you come back to a staged delivery plan, like a little bit more just in time, where the quantity that you purchase remains the same, but what gets delivered is maybe, say, a third of what you see in this one cube? You just might ask that. So it's hard to say from a waste perspective of inventory, what's the exact waste. but it just might be that, hey, there might be an opportunity to go back and look at purchasing plans and say, do we need to be buying so much? Because then we end up storing it, and we store it high, and that creates a safety problem that John's
I
referring to.
think that's a pretty key thing that you hit on there, because as a rule, because of the distance these are coming from the forge, they are coming at 40,000 pound shipments. And 40,000 pounds last us several weeks. And I don't know the time length that it lasts us, but the thing we have to remember in having 40,000 pounds of raw material coming in the door is more than likely they didn't show up the minute we needed them, so we still have raw stock on the shelf when that 40,000 pounds come in. Plus, we have to have a safety stock of machine parts on the shelf, so we may have 80,000 pounds of forgings on the shelf of that particular part in raw material and finished material.
So that's the classic sin of batch. I mean, because there's a large distance. Here's a very important relationship you should understand, that distance automatically impacts batch size, which impacts work in process, which impacts flow time. The more width you have, the more time it takes to get work out the door. So in logistics parlance, because you have a big distance, the forge shop says, I'll send you a big batch. So you pay the overhead and the carrying cost for storing it. Same, apply that to the shop. The moment you separate two process steps more than 3 to 6 feet, you batch. The moment you batch, you end up having queuing waste, transportation waste, inventory waste, and labor waste. So distance impacts inventory, period. And inventory impacts flow time. Simple equation, take it to the bank. Then?
I would say the biggest thing is the time of moving objects out of the way just to get to the racks, what I see. Not only the time of the guy that's moving it, but the time that he could be doing something else.
There you go.
Also, as Scott said, the aggravation of it affects morale. If a guy has to move something that another guy put in that place, it aggravates him.
And you don't know, depending on how much people get aggravated, what they could do.
The other thing to having smaller shipments come in and having maybe less safety stock on the shelf would be that would create more open pallet racking to put those boxes that are sitting on the floor up on the pallet rack instead of putting them on the floor. So it's a matter of purchasing, working with management, and management working with the employees who are placing this stuff out there to try to get the best utilization of the racking that we have, and creating some kind of work instructions so that they understand the procedure for incoming material and for placing things on the pallet rack, so that they understand that the rack has to be left accessible at all times, so that we don't move and remove parts time and time again.
See, you mentioned standard work. I mean, that's, I think, very important, that we're just in the warehousing area. But there's this whole area of study called lean warehouse. How do you apply lean thinking to storage? So, having standard work is very important, because then anybody that comes in can work in this place and not have a situation where what they do hurts somebody else's productivity when they come and work in this place. You mentioned about racking. Any kind of racking is considered muda or waste. So over here, this rack goes down here, and then there's an angular section of rack which comes out at an angle at this end, right?
Perpendicular to
So the
it.
question is that if you reduce how much you store, you could potentially remove that angled rack, which means you now have easy line of sight right through to the machine shop. So right now, this rack projecting out in the corner is preventing the rest of the shop from being able to know what's going on in this inventory area.
True.
So if you cut down the amount of inventory of a particular part, and the cubage which you have is being used now for more parts, who knows, you could eliminate this obstruction which prevents line of sight between the production portion of the facility and the storage portion of the facility. Another issue is that you don't have roller racks. That means these racks are flat.
Yes.
So you can't have loading from one end and pulling from the other. It's all load in and load out from the front face. I don't know if that's valuable, but in the typical supermarket that the Toyota production system implements in their factories, material comes in from one end of a rack and leaves at the other end, and they're inclined, so that gravity automatically moves the pallet, no matter how heavy is it, from delivery end to consumption end. Today, you have to use a forklift, which is cost of some sort, and delay of some sort, to move any pallet. So if you use gravity, it's cheap energy, zero cost of transportation. If you use flat racks with no conveyance capability, there's a cost of transportation. One last observation is, I remember when you had said, observed 5S failure with hoppers, A3 containers, and miscellaneous containers stored in front of racks, which limits accessibility. See, I have a bone to pick with those companies who would implement 5S purely for the purpose of 5S. I mean, you could have a wonderful clean machine shop, but the entire factory was laid out wrong. So keep in mind that 5S should not be a goal unto itself. It should be an enabler for traceability, for safety, for speed of flow, for visual control of the shop. So I think that's the question I asked, that you said 5S failure, but what is the impact on business, on performance, on morale? Find specific impact on the business, and then you can justify 5S failure and what you do about it. So your suggestion, need written instructions and training of material handlers on the use of the storage areas, goes back to the 5th S in 5S, sustain. So without instructions, without visual directions, here are examples of good storage practice, here are avoidable examples of bad storage practice. If you don't have that, then that hurts. So for example, this thing which we are doing today is an example of what you can provide people. Simple visual charts or videotapes that would train them how to apply 5S for productivity gains, for waste elimination.
The individual crates with forgings are moved over to a staging area, and these crates are normally moved with a forklift. The staging area is located up in the northwest corner of our building, and it just so happens that that's the last space, larger space we have available, so it became the staging area. This staging area generally starts from this point and then runs down to the toolboxes. And you can see that there are 5 or 6, maybe 7 different part numbers of items that are being staged here, ready to go on the first operation possibly, or maybe a multiple operation. Most of these items are raw material, but they can also be work in process as well. We recognize that the staging area is a wasted step, and many times the crates are taken directly to the machine, depending on during what shift they're needed and how often they're going to be used.
One of the first things I'd like to bring up is I see a lot of maybe unutilized individuals out there not moving or making parts or whatever, and this project and everything is not to show fault with any individual or anything that's going on out there. It's just to help utilize our time and the plant to its best potential. And with saying some of that, I've seen some individuals standing around, and some people were going for cranes and so forth. So I just want to bring up that most of this is not to show fault. It's just to try to bring out where we need to improve on as employees and management. as a team.
Some of the things I've seen, as Mark said on the video there, that you know, we have a staging area that's at the opposite end of our storage area. It doesn't seem to make a lot of sense to store our work in process or our storage forgings or whatever at the opposite end of our staging area, then pull it from our staging area, go 300 feet to our staging area, then maybe go back another 50 feet to the machine that we're going to run it at. I understand there is a little variance in shift. You know, we don't have the material hand drillers on second and third shift, so those guys aren't supposed to be on tow motors, correct?
Right.
So there is a need for it second, third, and the weekend shift.
We do have employees trained to operate the tow motor on second and third shift, but as a rule, the working supervisor is also a production employee, so they're to be producing parts, and if they're on a tow motor getting something off the pallet rack, they're not producing parts. So that's our aim, is to have everything staged at the end of first shift to cover second and third, so that these employees are not away from their machines.
You know, the fact you mentioned that there's a staging area and main storage in the receiving shipping racks, the issues of scheduling and awareness, you know, that what you would ideally want is at the start of the shift and during the shift, parts are taken directly from the receiving storage racks and delivered at the machines. There should be no storage, you know, there should be no staging. So it's almost like now you have two racks. One is the main receiving storage racks, and then you also have the staging area inventory. So there is some suggestion that scheduling effectiveness may need to be checked out. You know, you've got the system called Vista or whatever, that, you know, how clearly is the daily schedule communicated just in time, so that when the shift begins, at least the machinists, the operation 10, operation 20 machines automatically have parts delivered to them, and not that, you know, work gets staged and then when they need the work they walk up to the staging area and then bring the parts in to the machines. Because I understand that the staging area is much closer to your opt-in lead-off machines than receiving. So this has almost become like a second receiving storage shipping area by itself.
You're absolutely right.
So I think Vista needs to be looked at.
Yeah, and when you were watching the video of this staging area, there's parts there that is raw material, there's parts there that is solved material, there's parts there that is work in process that's had one operation completed and another operation to go yet. And for scheduling purposes, it's not always a flow of, okay, it's a lathe operation and then a mill operation, go directly to the mill. It comes back to staging from the lathe and then goes to the mill, which is okay. But in the video, you could see how the depth of those boxes, all those boxes are either placed by a pallet jack or by a tow motor. So if I come over and say, well, we need that box in the back, and it's the only box of that part, then we have to move 3, 4 boxes. And in the process of moving those boxes, we have to pull them out. We get the box out that we need. We take it to the location that we need. Then we have these boxes that we either put in the way of other boxes, or we have to put them back in that row again where we removed them from. And we don't know always what order those are going to be coming back out again. And we may put those 4 boxes back in that same row, and the next time we need a box out of that row, it's the back one again. So we have a lot of confusion and lost time with what should be in front, what should be in back, what are we going to need first, what are we going to need last. So if it's on pallet racking, either near the machine or just left in the receiving area, then we don't need to worry about it setting on the floor. It's taking up a lot of floor space. We don't need to worry about, well, should I put this in the front, should I put it in the back, is this going to come up first, is it going to come up last?
And it also says that your queuing time's large. Your timeline from the time you get your material till the time it actually goes and leaves our shop is longer than probably what it needs to be. If it's sitting around for that length of time and we're moving it that many times,
Yeah.
that could definitely be improved on.
See, again, remember I keep beating up on 5S as a goal unto itself. You mentioned confusion, you mentioned peak time. Those are measures, because all of that relates to how much time did it take you to bring that pallet of parts to the machine. That's the total time, right? So warehouse design is an area of expertise in industrial engineering by itself. So combine 5S with the science of organizing inventory. So like raw material should have its own area. WIP should not actually be there, but if it has to be there because the customer whacked your schedule, there should be a designated area. And finished goods should absolutely not be there. So if you did a 5S and you sorted and you found 3 types of inventory, there are 2 types of inventory which should probably not have been there in the first place. And at the best, you're using that staging area as a short-term raw material storage. Right? Now, we know cell design, right? We manufacturing people talk about U-shaped cells. The thought here is that you could think of a crab's pincers, like 2 shapes like that. If you could have like a W, so you have all your incoming inventories delivered from outside the portion, and whatever's being pulled out is pulled from the center. You need to have flow and circulation of your inventory even in the staging area. Otherwise, right now it's pretty much last in, first out.
Yeah.
What you dropped in first is going to take you a hell of a lot of time to pull out first. So you have to look at flow and losses even where you store inventory. So the concept of the supermarket, that's so powerful in terms of short-term designated inventory storage in the Toyota production system is very relevant here, but your solution has to be flexible to random pick and put. I've gone to distribution centers, there they've got roller conveyors that allow you to move big containers. Would possibly benefit you if you raised the storage area, put roller conveyors so that then at least people could push these big containers right down the length of the conveyor and then pick it up off either end with pallet jacks. So there's a lot of opportunity that if you have to store inventory, store the cheapest form, raw material, and then organize almost as if this itself was like a manufacturing cell that had the shape of a U or a W, which are the most efficient forms of arrangement of machines and people in small areas.
And we kind of actually noted that our lot sizes or our batch sizes are actually just because the lot sizes that they're coming off the trucks. And I mean, that might be 3,000 parts that's unloaded in one box off a truck, and we really only need to run a couple hundred parts, but we've chosen to run a batch size of that whole box of thousands of parts.
And that becomes a challenge. I think that it is easy for us to say, well, tell the forging supplier that when they send us this big carton, that 3x3x3, that inside of that they have these tubs or totes or smaller quantities. Like the example you gave that the delivery quantity is 2,000, but now I'm going to move inside the shop, I'm going to move in small batches of 100. It's easy for us to say, yeah, we should move smaller batches inside the shop, but I don't expect the supplier of forgings or bar stock to say, oh yeah, I'll pick up the cost of buying those smaller containers. So there is a kind of a give and take that it's convenient to kind of persist with the same container that the supplier built for you and not invest in having your own containers. But then that's the thing, that if you are going to move inside the shop using these cartons, hallelujah, God bless you. You've got work in process right up the ceiling.
But we're also using tow motors, and we could use floor jacks.
Yes.
We're moving with small rollers if we didn't have such large lot sizes that we're trying to handle.
And tow motors means fumes. Fumes means air contamination. You might say you're small and that you have good ventilation, but anytime you operate an internal combustion engine, you're paying a price.
And it's safer to move a floor jack than it is a tow motor.
I'm with you. Safety, I'm with you. I think that's why I think that most warehouses hire the NASCAR 500 retirees, that they're safe in there. Any other questions? We done a pretty good job on this one. I mean, over time, as you bring in other people, they'll have their own suggestions and comments. The idea is just keep that thinking going, you know. Some of the ideas may be expensive, some of them may be in conflict with other ideas, but what's most important is that, you know, at the end of all this analysis paralysis, what you really want is a recognition. Why are these wastes occurring? What's it costing us? How is it impacting delivery time? Safety. Most of all, do you have an action plan? How to reduce it or eliminate it? Because whatever you do with waste goes back to cost reduction, which jacks up your profit margin, even if you had no increase in sales. So waste elimination is good. It's not the end all be all, but it's a darn good start.
How about sustaining something?
It's attitude or reinforcement. So like, you know, 5S, you know, they will recommend people, inspectors who have 5S rating sheets. You can only push people so far. But again, you know, people would like to be rewarded in some cases. So initially you could start off with pizzas and caps and big posters, but at a certain point it has to be that the president, for example, might run a spot check. And not that he goes and swears at people for making a mistake, but if he says, good job, I saw what you did, I like that. If you go walk to people's side and say, good job, I like what you saw. Hey, I know how I feel when my boss praises me. I know how my students feel when I advise them that, hey, good job, you know. So sustainment is purely keep on looking for an opportunity. One thought I've had is that if you, the action team, the management team, could put up like a poster, like a value stream map, or any other appropriate approximations for high mix, and you could potentially say, look, here's our constraint, here's our biggest opportunity, we need ideas on this area. That might sustain, because that way the employees are always having some direction that focus your improvement thinking on this area, because that's our immediate opportunity. So I know that's putting back work onto your shoulders, but I think sustainment essentially comes about with work and projecting benefits. One company I know had a simple display. Dollars shipped this month as of now, and it was in the lunchroom. Now you keep displaying that thing, and there's a little Excel plot which shows how we did. And the boss says, we did this better because you contributed. I think good actions, good thoughts, and good words always have a good impact. So sustainment is a challenge. Small companies are challenged for time and resources, but if the attitude is there, and you start seeing waste elimination as a means of releasing time for you to do more value-adding work, it's a good, fulfilling circle.
Okay, after completing Operation 10, the work in process gets moved either by a pallet jack or forklift by either the material handler or the operator himself will move the parts to op number 20, which is a horizontal machining center. And the parts are usually dropped off in their container at or near the location of the blue cart. Then the parts are picked up individually, loaded into the machined, which is op 30, and then moved into another container that is located in this area. After completing op 20, the parts are moved over to our quality assurance area for inspection. These parts are usually moved by a forklift or a pallet jack, and usually moved by the material handler.
They're moving it to QA right now.
Well, my observation in that was, I saw that there was a basket of parts sitting in that area at the lathe that should not really have been sitting there. I believe, if I remember right when we taped that, it was a quality issue on the parts. they probably should have been moved out of that area.
That possibly could have been. I didn't pay that close attention to it. That's what happens when we run these large batch sizes through there, that a lot of times we do not catch any kind of error or anything wrong with the parts until it's too late, until we've ran large numbers of parts and QA's checking them for probably the first time, a completely final part, and we may have 500 or 600 parts that they're checking and find something bad with them. And with these large lot sizes, it's not until it's way too late that we catch these problems.
Running a 3-shift operation, we have at least 3 different operators running those parts in a 24-hour period. And historically, some parts that we run, we're not able to actually mark the parts, and the shifts will mix their parts. And we have not been keeping a separate box or basket for each shift. So it's hard to have traceability of when the parts were made, other than they're in the bottom of the basket, then the next level or whatever. But like John said, we do a first piece inspection, but I think maybe we're not putting enough emphasis on in-process inspection, of having QA doing more inspections at the machine instead of waiting until the parts are all ran out and then doing an inspection saying, oh, we got bad parts. So then they have to do a piece-by-piece inspection through the entire lot of 500 or 600 parts.
So isn't the operator himself certified to inspect their work, or you need to have QA as an outside reinforcement?
The outside, yes. QA has to be the outside reinforcement to in-process inspection, because sometimes in-process inspection fails depending on how closely it's adhered to. We've actually had parts, not this particular part, but we've actually had parts run before that were found in the lot of the run that had no groove in them. The grooving insert broke and they were ran without a groove, and it wasn't caught in the process.
Wouldn't it be more logical to have, after watching and taping this video, it seemed like we bashed all of our stuff to QC. Wouldn't it make more sense to have a roaming inspector, like every hour, say, okay, that layer, that box is certified, okay, that layer, that box is certified, instead of going to QC, taking all them layers out, going all the way to the bottom, reorganizing them, checking each one from each layer? I mean,
Yeah,
would it be...
I'm with you. I mean, like, one concept from the Toyota production system, which I feel tends to be biased towards high volume assembly, but one concept from that system which I think applies very well in job shop lean is the concept of a water strider or a water spider. The idea is that there's this insect that on lake, stagnant water, you'll see darting across the surface of the lake in that one area looking for food. So the concept in the factory is a highly skilled, multifunction individual who's pretty much able to deliver materials, who is able to back up people on work if they need a break. So that means they're able to do a lot of support activities at different areas of the factory, because they're kind of roving around the factory. That's why they call it a water strider.
Including inspection.
Including inspection. So, if you think of a small shop, if you're a small shop, you do not have to look too far to see ends of the building. So if the machinist could set up little flags, and these flags could be viewed from the QA office, or little walkie-talkie communications, so that the water strider is running around, the inspector acts like a water strider running around the shop, quickly doing one-piece inspections on small lots around different areas. That could be brought together. So instead of having people send big batches of parts to QA and then finding the problem with scrap, as soon as they do the first 2 pieces of a prove-out run, they set up a flag, and this person or persons are walking around the shop, picking up inspections. The big thing in your shop is you're sending everything to QA, and you tend to use the big containers. So naturally sending a batch to QA. And the machinists don't care about whether QA is backed up with how much queues of work that they have to inspect already. There's like a push scheduling occurring between the machines providing the work and the QA people providing the inspection service. So if there was more communication, this roving inspector person that Ben mentions, visual triggers that I need inspection, come do it, that would be a big help. And above all, big containers. Everywhere I see you've got big containers of parts, and everybody's filling up these containers before they get moved. So you're kind of doing overproduction at your various machines.
Yeah, I seen on this part of the tape where we were doing a sequence 20, and the next sequence was a 10, and it was going to 20, and the parts were not even at that location. So that means that those parts were in queue somewhere just waiting to be machined. And when that happens, that means your timeline that you use from the time you get your material until the time the parts are shipped are a lot longer than what that needs to be. And what you want is that timeline as short as possible. And when I see that we have parts sitting over in staging, waiting on another machine to be open to run it, that means that our timeline's longer than it should be.
You mentioned timeline, and I know that Scott's also had a couple of comments to make. So let me start off that discussion. If you look at the total videotaping timeline that we had for this one part, it took us about 19 minutes and 27 seconds totally. So we are not really capturing the processing time, the real queue delays. We really haven't got that timeline. This is just 20 minutes of pure flow. But even in that 20 minutes, look, Operation 10 is being begun 4 minutes and 40 seconds after we kind of stapled ourselves to the part. So that's about 25% of the total time of flow is done no value adding work. Now imagine expanding this into your shop, and you've got some numbers, John, right? The real days of delays between operations. So Scott, you want to add a little bit about value adding time versus?
Yeah, well, that's what I was going to say about our form that we use, our job traveler. When the job traveler comes out into the shop, it has a time on there that's allotted for setup, a time on there that's allotted for the production of the part, and that's the cycle time for that part. So if you take the total timeline of the video that's around 19 or 20 minutes, and if you were to put all these items on that job traveler, maybe at the end we would see that only maybe 30 or 35% of that time is actually value added that the customer is willing to pay for. And what the job traveler should reflect is what the customer is willing to pay for, because it's got the process. They're paying for a setup, they're paying for production of the part, they're paying for inspection of the part, is quality of the part, and I'm paying for outside services that we have to get done, like heat treating or plating or something like that.
Cash flow, flow of cash. So if you took all this waste and delay, etc., and we started saying, how quickly does the cash we put in on a setup, on an operation, how quickly does that cash come back to us as a sale from the customer? The more that these wastes don't flow your part through the system, your cash flow gets affected. So, you can think in terms of inventory turns, like how quickly do I turn around every dollar I put in to make the part? So if 25% of your time in the ideal flow is doing nothing, imagine your cash flow inefficiencies during real-time execution on each and every part. John, you had something?
Yes, I've seen how critical this type of timeline is and how to measure it. And we took a part out there that actually we did pretty good on. Our value added ratio was 43%. But we started to actually see what we could do as far as getting that part to the next operation, getting that part from right off the truck and starting small lot sizes that we would be capable of getting up to 97% efficiency and value added time to it. So it's possible, it's very possible to do it. We just have to do it.
You have to do it because the value added ratio essentially is a simple ratio which up in the numerator you're essentially putting in your processing time. Not setup, nothing, just pure processing time, because if you did not process the part will not be complete. So the numerator is value added time divided by the total time that the job spent in the shop. So that total time is, again, your value added time plus your total non-value added time. So if you have a ratio of 43%, that's pretty good. And if you make that 97%, what you're essentially doing is maximizing the velocity of cash flow. I mean, you can't get better than 97%. So in terms of a future step of this project would be, we've done just one part. I mean, Ben tells me that, in a typical year, you have at least 1,000 active parts that you process. So the goal would be, now we look at your entire product mix, we look at the flows of all of them, we pick apart families, and then we kind of design either physical cells or virtual cells, because that way, in a manufacturing cell, your non-value added time really can be whacked. So your value added ratios of 97% can easily be achieved if your business was concentrated in multiple cells, and whatever you bid on, any parts you brought in pretty much could fit into one of those cells. So if you're looking at job shop lean, how do you go beyond these basics? The next step would be look at all the parts flows and do the same kind of waste analysis around families of parts. So for example, there might be a bunch of parts which have the same routing as part number 026DC104. So imagine all the savings you have identified through improvement strategies for this one part potentially could be magnified because all other parts moving the same way with the same inefficiencies would have been whacked. Well, we have pretty much completed our discussion session. The intention again is that when you go and work in your company, and you may be a small manufacturer with business of about 10 million to 100 million, you can't think that lean is not for you. At the same time, you should understand that a different flavor, a different adaptation of lean may be better for you than just verbatim adopting the best practices of the Toyota production system. As far as the initial work that you would have to do, here's a quick summary. You go and select a sample of high performance parts because that's where you wish to focus your attention. Then you do what is called a product revenue volume analysis, and you kind of categorize your parts. Then you pick at least one part. To get your feet wet, pick one important part. Find its routing, obtain the layout of the facility, then simply map the routing as it flows, as this part would typically flow through the facility. Once you have created that basic spaghetti diagram, then what I would like you to do is to further classify the basic elements of any process flow: operation, transport, inspection, delay, and inventory. Having created that basic flow process map, bring out your video camera. Either that video could go on the America's Funniest Videos or America's Most Wanted. I leave that to you. But the idea is that this video camera is now going to be stapled to this particular part, and it will start in raw material where the part is either a forging or bar stock or a stamping or whatever, and it will end at shipping in the container where this particular part is going to be sent to the customer. With this video camera on the part, I would like you to videotape this thing called the facility walkthrough, because you are now trying to capture visually for other people to see what are the various forms of waste that get tacked on as a cost or a delay onto this part. So the session which you saw was post videotaping. You brought the videotape in, and all that you're doing at this point is, when you're looking through the videotape, you're breaking it up into clear segments, and the segments typically would be transportation, operation, inspection, just queuing, and inventory. In some cases, there may be decision blocks where, depending on the condition of the part, it may follow different routes. But typically, most process flows of physical products tend to be broken up into these 5 elements. When you're walking through the video, again, observe the various wastes which you see in each segment. Try to measure it. How is it impacting the bottom line? How is it costing you? How is it delaying? How is it hurting people? Or how is it damaging morale? There has to be a value of non-value. Once you do that, try and ask a little bit about why. Why do you think that waste is occurring? I'll give you a very prominent example. 95% of the total time that a part takes to move through a factory is typically captured in 2 types of waste: transportation waste and queuing waste. Why does that happen? Because consecutive machines in the process flow of the part are not next to each other. By next to each other, I mean at the most about 3 to 6 feet of separation. So the moment that two consecutive operation points are not physically co-located, that is the reason why these two major forms of waste occur. Guess what happens further? When the distance of separation between two consecutive points exceeds about 3 to 6 feet, the ability to achieve one piece flow, to make one part and move one part to the next machine is absolutely lost. How do we compensate? We batch. What's a batch? A big heavy container full of many parts. When you have a big heavy container, it needs a material handling device like a forklift. These devices aren't easily available because somebody else has to be told to bring that device. So see, the moment that the distance of separation between two processing points exceeds 3 to 6 feet, all the wastes occur. Even scrap increases. Why? Because this man produces a bunch of bad parts, puts them into a batch, all of them are bad, and they don't get picked up because he or she was not trained or authorized to inspect the parts for themselves. So distance of separation is a key root cause for the inventory, transportation, and queuing forms of waste. Finally, when you've observed these videos and recorded your wastes, you must leave behind for other people, other employees to see how you thought about potentially improving that activity to either eliminate the step, the waste, or to reduce the waste. So as an industrial engineer, when I look at a process map and I look at activities being performed and I think of certain activities as being non-value adding, here's the thought process I adopt. Can I eliminate the step? Well, if I can't do that, can I combine the step with some other steps so that I eliminate transportation? If I can't combine them, can I change the sequence so that maybe I reduce changeover losses? Step 4, if I cannot eliminate, I can't combine, I can't change the sequence, can I at least simplify the step? Simplification might be simple things like cutting scrap rate, cutting setup time, reducing cycle time. After that, you might say, can I speed up the step further? That is typically done by what we call parallel processing. So if you have a big batch, could, for example, 2 machines be running the same parts? If you have a symmetric product, could 2 people be assembling it from 2 ends of the product? That's how you have the 5th step of process improvement. You speed up the activity. Finally, when you've made all possible improvements on the step, only then you automate it to bring in the consistency of mechanical automation. So when you end your waste elimination journey, which is like a 101 approach to lean or job shop lean or Toyota lean, you should have ideas for improvement because on that you act. So it should not just be finding problems and finding faults with people, but at the end of whatever you do, your employees who you are expecting now to start thinking about improvement on a day in, day out basis, they should see that, hey, the president, the production manager, the engineering manager, the cost estimator, all those so-called supreme beings in the company, they themselves tax their brains to improve and change the way they were working. Because if you don't change how you're working, because you saw waste and irrationality, it's no point talking about let's go lean. It's one thing to pick up a book like Lean Thinking or The Go, 2 very good books, and say, oh, I want some of that lean, like you're buying something off some grocery store. It's another thing to internalize that. And again, as an industrial engineer, I've found it most beneficial to take lean thinking, theory of constraints, Six Sigma, and my own industrial engineering learning and put it all together. So improvement is free. Well, not exactly free. Anybody can achieve it, but it takes some effort. And this is like a first level approach that I can guarantee you, if you have the energy and the ability and the desire of people like Team PR, even you can do very good. Thank you for your time.